is my JIP presentation for task 13, sponge. And I'm just gonna go ahead with my preliminary considerations so that every one of you knows what my tasks were. So, how is a sponge designed? How can a sponge soak up water? Which materials are best at soaking up water? And how could you determine the mass of water that's contained in a sponge that just recently has soaked up water? And for the experimental considerations, how is the size of a sponge related to its water absorption capacity? How is the water absorption changed with multiple wipes? How does the water absorption capacity depend on the wiping speed? And what sponge is best at soaking up water? And how wet could the surface be? So, at first, how is a sponge defined? How can a sponge soak up water? Well, the effect is called capillarity. It only works in tight tubes where the water slowly rises. The sponge consists of many little tubes which are called capillaries. Water and sponge molecules attract each other. The effect of the attraction between two molecules of not the same material is called adhesion. If the adhetic forces are strong enough, the water is soaked up into the sponge. The other water particles get soaked up too because of the forces of cohesion, which is the force between two molecules or more, of course, of the same material, which in this case is water. And which materials are best at soaking up water? Well, the water absorption capacity in general is called hygroscopy. And especially salts and hydroxides soak up water, but there it's mostly out of the air and not that relevant for textiles. For this case, for the sponge, it's made mostly out of viscose, which main ingredient is cellulose, which is a synthetic material made out of plant remains, so it's biodegradable. And those materials can store water better than others. That's why they're used as a material for sponges. And how could you determine the mass of water that's contained in a sponge? Well, the only logical way I thought about this was like you could measure the weight of the sponge in a dry state, then you wipe up whatever kind of fluid you want, and then you measure the weight of the wet sponge and you take the difference between these two measurements, and the difference should be the mass of the contained water. Now for the experimental considerations. For the setup, we at first need the materials. So of course we need a sponge, something where we could regulate the water we pour onto a surface, where I used a syringe. We need a surface and we need water. And I thought like I need a hypothesis so that I could make some statements and then prove or falsify them. So I think that if you wipe slowly, the water has more time to be soaked up. So if you wipe slowly, more water is absorbed. And I also think that a wet sponge absorbs more water because the forces of cohesion are stronger if there is already water in the sponge, and therefore more water is soaked up. Now for the execution, you at first have to moisturize the surface with the syringe with an optional amount of water. I took there 50 milliliter. Then you take the first try with a dry sponge and wipe slowly over the surface. For the second try, you have to wipe fast with the same conditions, so a same dry sponge as in the first try. Yeah, and in order to prove or falsify the second hypothesis I had, you have to moisturize the sponge with an optional amount again of water. I took there 10 milliliter, it should be less than the overall volume of the sponge. And then you have to repeat what you've done for the first two tries, so one slow wipe and one fast wipe. And the results of that can be seen in the following videos. So in this clip we see the experiment with a dry sponge and a slow wipe, and as you can see there isn't really any soaking up going on because the sponge is dry, and even after several wipes there hasn't really been any water soaked up. There was a little amount that's been soaked up, but it was pretty insignificant to this. In this video you just can see me wiping over this wet surface with a dry sponge pretty fast, so the water hasn't been soaked up at all. It just has been pushed away from the surface and onto my floor. So I guess that in order to get soaked up, the water needs time. So what we have in this short clip is me with a wet sponge. I've moisturized it with 10 milliliter of water, and the water actually got soaked up. I wiped pretty slowly and most of the water got soaked up. There were some remains on the surface, but most of it got really soaked up into the sponge way better than in the first two attempts. So as you can see in this last video, I have a wet sponge with a fast wipe over this wet surface, and unexpectedly it actually soaked up pretty much of the water. I mean, I thought that like the wet sponge would soak up more than the dry one did, because the dry one did literally nothing, but it actually left pretty less of the water on the surface. So now for my final conclusion to the experimental part of this presentation. As I thought, the wiping speed did actually affect the water absorption on the sponges. As you could see on the dry sponge, the slow wipe dry sponge did soak up a little water. As I said already to the video, the part was really it was pretty insignificant, but it was still something. Like when I wiped fast over the dry sponge, it didn't really do anything at all. And when I wipe with the wet sponge, there was water absorption, but the water absorption was way higher and at the slow wipe sponge than it was at the fast wipe sponge. And that's just because the water needs time to really rise in those capillaries. And if you wipe fast, the water has no time to basically interact with the sponge and get soaked into it. And that's why my hypotheses were proven correct, and some of the experimental considerations were on this topic. And I actually also had a experiment to whether or not the mass has anything to do with the water absorption, but in the experiment I didn't really, well, the mass didn't seem to matter, so I just didn't show that experiment because it hadn't anything to do with the final result. It was insignificant. So that's it for my presentation. I hope you guys enjoyed it. Goodbye.